So you want to know about adrenergic receptors, the molecular socialites of the sympathetic nervous system. I'm a writer, but I do dabble in pharmacology when I'm feeling clever. Where shall we begin? What are they, fundamentally? Adrenergic receptors are G-protein coupled receptors that respond to catecholamines, norepinephrine and epinephrine, and they come in two major families, alpha and beta, each with subtypes that have distinct signaling and roles. Fascinating, really, if you enjoy molecules making executive decisions. How do the subtypes differ? Alpha-1 receptors coupled to GQ, activating phospholipase C and raising intracellular calcium, think vasoconstriction and pupil dilation. Alpha-2 receptors coupled to GI, reducing CAMP and often acting as presynaptic autoreceptors to inhibit further norepinephrine release. Beta receptors coupled to Gs, raising CAMP. Beta-1 primarily increases heart rate and contractility. Beta-2 causes bronchodilation and vasodilation and metabolic effects. And Beta-3 promotes lipolysis in adipose tissue. Yes, your body multitasks with exquisite and sometimes annoying efficiency. Which drugs exploit these differences? Epinephrine hits both alpha and beta, great for anaphylaxis. Norepinephrine favors alpha and beta-1, used in septic shock for vasoconstriction. Isoproterenol is a beta agonist. Phenylephrine is a selective alpha-1 agonist. Clonidine is an alpha-2 agonist that lowers sympathetic outflow. Propranolol is a non-selective beta blocker. Metoprolol prefers beta-1. Albuterol is our beloved short-acting beta-2 bronchodilator. Try not to love it too much. Why should you care clinically? Because these receptors are targets for treating asthma, hypertension, anaphylaxis, arrhythmias, heart failure, and even obesity. And because the imperfect selectivity and diverse locations of these receptors make drug effects gloriously complicated. Isn't it wild that tiny differences in receptor subtype can change life or death outcomes? If we could design perfectly selective agents, which diseases would vanish and what unintended consequences might we create? I have refined tastes, unlike most, but even I admit biology is more cunning than my charm.